things I've learned from Simon. He's an absolute wealth of knowledge and an extremely generous sharer of it. And probably, I think there's lots of things that I love about Simon, but one of them is the long history that Simon's had of making iterative changes to a system as his knowledge has grown, and he's tried different things in that. And on reflection, knowing what he knows now, what that could look like, what the potential for looks like, and particularly in an arable system. So super excited to have him here. I'll let him introduce himself beyond that. So yeah, thanks very much, Simon. Looking forward to it. Cheers.
Thanks, Sam. He's always good to put to work. Comes and stays for a few days and we get a lot done. And I don't have to pay him, so it's great. So I'm Simon Osborne, obviously. And our family farm was founded by my great-grandfather in 1864 after he'd been to the gold fields and done various other things. 280 hectares of arable grain and seed production. I don't suppose you'll be know what these soil types are, but Waterton shallow clay loam is considered in Canterbury to probably be the last soil that you would crop on. There's no lies in its description. It's shallow clay loam, so it's generally about a foot deep on top of shingle, but we do have underground water at about 600, so you can just knock a hole in the ground, knock a pipe in the ground and stick a pump on it and away you go. Temuka clay loam on a block by Coast Ford, which is next to the Selwyn River, which has been infamous in the news media, and that it also has Wakanui and Templeton silt loam. But the Temuka clay loam is interesting. It's ranges between 1 and 4 metres deep, and it's clay on clay, and it's seriously strong soil. And again, traditionally not a cropping soil, because in a traditional conventional cropping situation, they go for the Wakanui and Templeton silt loams because they withstand cultivation. They have no structure, no guts, and they fall to bits at the sign of a machine touching them, so they're perfect for cropping. And they don't, they have no structure, so there's no structure to lose, essentially. So anyway, on the home block, in the mid-70s, the soil structure had got so bad that we just didn't have machinery to cultivate it anymore. And so Dad said, well, what are we going to do? And it was about the time that Roundup came on the market, and thought, and no-till was a happening thing, so I thought we'll give that a go. And everybody in Canterbury rushed in to no-till, and then a couple of years later everybody rushed back out again because they just couldn't make it work. And that's probably when the belligerence gene kicked in, and I thought, well, bugger it, actually we can see some benefits here and see some potential, so we just persevered with it. I finished school, went to university, went to Australia and worked in the oil industry, travelled right through Southeast Asia, through the Soviet Union, ending up in the UK for a year, worked on a farm there. Couldn't believe how ruined the soils were there. They were just absolutely destroyed. And thought, so in 1992, beginning of 1992, I came home, and I bought a piece of land in 1989 that Dad had sort of said, right, you're buying that piece of land. And he lent me half the money, and the bank lent me the other half, and he said, I'll farm it while you go away and do what you need to do, and then when you come home, you're into it. And so we did that. By the way, I paid $600 an acre for that land. And I sold some of it a few years ago for $10,000, but and bought some better stuff down the road, so that was good. So that's sort of the background. So this presentation is essentially just, I guess, the best way I can explain what I do is to understand why I do what I do, and that's going a journey in my mind, which probably isn't a great place to visit, but just give you an idea of how I've come to be where I am and why I do things the way I do. So I'm an experimental farmer, So in terms of day-to-day practice and what you should do and shouldn't do, I wouldn't listen to a word of it. So what do I see soil as? Well, I see soil as a healthy soil as a complex web of life, powered by the sun and fed by plants. And the plant is always the interchange between the gas and the soil and the sun and the soil. And these are a couple of pictures I picked up off the internet. Well, that's an after harvest one, but you've got several trillion of those every square metre of soil. Nice little pictures off the internet. They're not necessarily scientifically correct, but they illustrate a point of, you've got a big base of very small things and a small base of very large things, and that's the soil food web, which is, in my mind, a very real thing. So with that in mind, how do we make a productive agro ecosystem? Because I see the whole farm as an ecosystem. So the integrated management systems encompass the whole farm and over a number of years. So you're never thinking of anything in isolation. If I need to do something expensive in a paddock as a remediation or whatever, I don't look at it as a cost in that. Well, I mean, obviously it's in the books as a cost in that year, but you're spending for a lifetime, essentially. So what do we do? Well, these are just a few quick pictures of what we day-to-day management of the farm. So after harvest, that's a cereal wheat crop. I run through. I don't have a cross lot, so I run through a couple of times with the mulch on the diagonal, and that puts the stubble on the ground, because I've tried using standing stubble over the years, and with the extreme winds we get in the spring, the roots have rotted off. You've got straw like this, the wind tips it over and then it all piles up against the fence. So I get it down so there's only that much, and that's like a bristle on the chin. It's like Velcro, and it'll hold that bed of straw in place, and then we can plant into that. I build and engineer my own machinery, so that's a fifth iteration of my particular drill, and a 50-year-old tractor that I did a bare metal rebuild on for those who've got iron disease like me. But anyway, I know most people here hate machinery, so I won't bore you with that. So that's one way of doing it. This is spring sown radish crop. So there's as Mike Porter, for those of you on the WhatsApp would say, there's a balls high cover crop. We spray it with Roundup, and then in this particular scenario, because it's hybrid radish and you're only planting 300 grams of seed per hectare, ran it through the silage chopper and then planted in there, and you've got a nice bed which suppresses weeds. The only opportunity for weeds really is in the seed row where you've disturbed the soil, and then same here with peas into an old fescue paddock, and peas into a cover crop, and then there's a cover crop. So just a few basic simple things. So I'd just like to make a few brief comments about the nature of the science industry in New Zealand. So since we live in an age where technology is going to solve all our problems, and we don't need to panic because the future is in the hands of those people who are developing this technology, and we can just all shut up and get on with our lives and do what we're told. So farmers have become consumers of retail science. New Zealand science has become increasingly irrelevant to farmers as it's been focused on producing marketable IP or products and tools for regulation, which in Canterbury, and living in the first catchment to go through the whole round of nutrient discharge consents and all that sort of thing, is an absolutely joyful experience. But you've got all these experts who've done all this work, and it's all theoretical, but it is what it is. Knowledge has become monetised and not used to educate, empower and facilitate positive change, which is why Nigel and Jono and I set up Quorum Sense, because we wanted to facilitate the transfer of knowledge freely, expert knowledge freely amongst farmers, because we see farmers as the solution to most things in society. New Zealand ag science has failed to explore new opportunities that leverage biological function of our agricultural ecosystems. And there are a large number of scientists, and I've met a number of them since this journey began, closeted away in CRIs, who are doing absolutely amazing work that is so useful to farmers and it's never communicated. So I was at Steve Ratton's funeral the other day, and I got talking to this guy, and I said, "Oh, you know, talk about Gwen Grillet, who's also on the board of Quorum, senior scientist at Landcare," and I said, "Oh, you know," he said, "Oh, I work for Landcare," and I said, "Oh, you've got to value these people like Gwen," and blah 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 blah. Got really stuck into him, and he said, "Well, actually, I'm her boss." So I think he got the message of where I was coming from anyway. But, so New Zealand farmers curious about biological function are forced to rely on overseas research, which is the most visible, which has been carried out in a continental and semi-arid climates with very old soils. The young soils and maritime climate of New Zealand often make said research only partly relevant to our conditions, leading to a lot of resource being dedicated to adaptation of the systems to New Zealand. So just a wee example of how technology is going to solve all our problems. We've got a problem with nitrates in our water, so the solution is to develop nitrogen fertiliser products that have basically antibiotics in them, which is N-butyl 5-phosphoric triamine, NBPT, which Ravensdown produce a product called N-Protect. So as a shareholder of Ravensdown, I feel entitled to comment on what they do. Now, NBPT, if you look at the HASNO safety data, the material safety data sheet from the manufacturer of that product, it's an incredibly dangerous product. If you're pregnant, you shouldn't go anywhere near it. You shouldn't breathe it. You shouldn't touch it. And that's on the, but because it's combined with urea in a product, it's not necessary to put that information out there. So, technology is a great thing. And AgriSearch have got this new GMO ryegrass, which is, as they have said in the press, it's going to put $900 on the bottom line of every hectare of every dairy farm in the country. Well, what a load of crap. It hasn't even been properly tested yet. So there's people making some pretty bold claims about science. And, the only reason I really bring this up is because regenerative agriculture, and the word regenerative doesn't appear anywhere in my presentation, I don't think, has had an incredibly bad rap from the science community in New Zealand who with the lack of anything better to do with this time, have decided that it's their pet hate at the moment. Rather than facilitating the transfer of knowledge between farmers who have actually been doing a lot of these practices for many, many years. So, the things we need to do to fix the world are simple. Basically, everybody needs to consume less. We need to reduce our impact on our ecosystems. We need to stop cultivating where we can. In a pastoral situation where every few years you want to go and cultivate a paddock to re-establish a pasture, it's neither here nor there. But on a cropping farm where you might be doing it twice a year, big issue. And we need to leverage the power of biology, because the plants have first moved onto land about 450 million years ago, and all they were was simple symbioses of the very first plants were basically lichens, which are either a cyanobacteria or an algae combined with a fungus. And then as they lived and decayed, they created soil in their detritus, and then that allowed more complex organisms to move onto land. And the first land plants didn't have roots, they just used fungi as their root systems. So, everything is a symbiosis. I mean, if you think you're a human being, actually only 2% of your DNA is human, the rest of it's bacteria. So we aren't really what we think we are. We're just a taxi. I think it was Nicole said that. We're just big bacterial taxis. The taxis, the bacteria basically, work out metabolism and get us to carry them to wherever they want us to go and do whatever we want to do. So, just where is the science? So I'm going to stop ranting about this shortly. So Steve Ratton put this up at his professorial lecture back in May 2019, and there's the number of papers that are published every year globally. They did a search. This is actually a piece of research in its own right, and anybody wants it, I've got it. But you know, back in 2016 there were around 8,000 papers a year. So these couple of people who are very vocal in the press get up and say, well, show us the science. Well, I say, well, don't be so bloody lazy, go and look it up. You can read 8,000 papers from last year. If you've got time to do that, then you know, maybe they'll stop yapping on so much, but anyway. So another piece of research he did, just looking at the step change. So there are the things that are sort of the threshold levels for a redesigned farming community. And 163 million farms globally. So 29% of farmers globally have gone down this road, but only on 9% of the land. So it's obviously all the small farmers who have seen the value here. So the people in this room interested in this, sorry to say, you're not really pioneers. You know, 29% of the farmers around the globe have already sort of got there to some way, which is good. So what do I focus on in my, so fecundity, fertility management. So fecundity in terms of soil is availability and cycling of nutrients, and I guess fertility is what's in the soil, the base fertility. What the fertiliser company reps and everybody else talk about is the fertility. And a few years ago I tested my soil, so I thought, well, if I'm going to start pulling fertiliser out of the system and playing around, I thought, well, what the hell's there in the first place? So I sent some soil off to New South Wales and the University of Lismore, New South Wales, and they do a nice test which gives you some totals for what you've got. And we identified that we've got, 2.5 tonnes per hectare of phosphate and loads of potassium, and everything's there. We're a wee bit short on trace elements, which the way we've been farming for the last 150 years is not surprising. So okay, let's say, well, we don't need to apply base fertiliser on our particular property. I wouldn't. So this is a mind exercise for me, and then a farm exercise for me. So
Simon, is that total nutrients, not available nutrients?
Yeah, that's where the fecundity comes in. How do you free up? So you need to understand those mechanisms of how nutrients cycle in the soil. How did soil build in the first place? Because it didn't just suddenly appear. It accumulated over time, and how did that happen? So the first thing, I guess, in that respect, is to stop erosion, and I'm being given time. So lots of closed loops. So I don't adhere to the depletion doctrine, which is if you take 5 kilos of this out, you have to put 5 kilos back, because we put so much on. How do we get back what we've already done? So cover crops, and that's actually a crop of buckwheat which was planted with Phacelia and veg that I harvested the other day. There's your crimson clovers, and here's a cover crop that was planted recently, and that we've had bugger all rain this year. And there's the mat of straw from the wheat harvest, and that's come with just moisture that's in the soil. It's subsequently been irrigated because I just wanted to get it away, but there was enough. We had enough moisture stored through the summer for that. And those girls, they're all sitting down. Doesn't look as though there's anything there. They've been in there a week, not particularly interested in moving. So that's, and there was a lot of fat hen and stuff came back after summer thistles, and they just ate the lot. And they're doing very well, and no poos on them. So companion cropping is one option, and I'll just have to run through this. So we're looking, okay, right there. So that's a lupin, and you can see it's just got a taproot. It's a non-mycorrhizal plant, and there's a Phacelia plant. So that's you've got different root types. They scavenge different nutrients from the soil. They bring that up into the foliage. We then put the foliage back on the top. The worms and the microbes take that down into the soil. We've essentially freed up minerals for the next crop, and it works. So here's one experiment we did. It's a crop of peas. After harvest, planted Phacelia and Crimson Clover, my drills in 10-inch rows in the ground, so that was in February, and then in April you guys become seller. So that's a way of mobilising, and then your different companion crops there. You've got Crimson Clover, oats and vetch. There's oats and Crimson Clover and oats and vetch, and it's amazing the different height there. And there's Phacelia and wheat, and none of those crops have had any fertiliser. And that's the product we get at the end. And then you have to rely on seed juicing technology to separate the seeds out, which is size, weight, and in the case of very valuable seeds, you can do it with colour as well. The second, I guess, string to the bow is the grazing thing. So here's, I've run this trial for 3 years, so this is last year's one. Planted on the 25th of April, that was on the 29th of May. By the 17th of August, it was, knee high or just below. Deck it, completely skin it, and within about 7 days it's 4 inches high again, and here we are. So these photos are actually all taken in the same location, and that's 31st of October, just at air emergence. So we didn't, with grazing at that time of the year, it took out all the broadleaf weeds, so we didn't have to put herbicide on the crop, and no fertiliser to that point. Then a bit of nitrogen just to get it through, to get the protein up. So we're using about a third of the amount of nitrogen that traditional cropping farms use to achieve the same result.
Sorry, in what form?
Sorry?
In what form would you apply the nitrogen?
I use urea early because we want nitrate for vegetative growth, and then I use ammonium sulphate later on because you want that for your reproductive and grain quality. Moving right along. So here he is put to work, Sam. So the next thing is bioinoculant. So we want to, the idea is to enhance the bacterial function of the soil. Now the microbes are all living in the soil, and we just thought, well, we'll try this thing. So we made these Johnson Sioux biodigesters, which is a very high quality, low volume thing that we're going to add at about 2 kilograms per hectare to try and encourage that association, the plant to form early associations with its soil environment microbes. So that's, we found a use for the old side roll irrigators, cut them out and bored holes in them so that we're making an aerobic, this is a static aerobic composting system. And here it is the other day. So it's sunk right down, and under the microscope we've got fungal spores and protozoa, soft body flagellates and things, organisms. So there's a good diversity of fungal spores there, and I did lots of slides and found lots and lots of species, and what we're trying to do is build up the broadest number of species of microbes, and then just introduce them in very small quantities. We've got our soil organic matters are up around the 10% that we've built over the last 50 years, and so you've got to, for these things to survive, you've got to build a house and you've got to feed them, and so you've got to have a soil structure and you've got to have the feed source. So, getting back to that biological function. This is linseed roots, and this is just to illustrate how plants actually feed directly from the soil. So you can see that fine root material there, that's those ones there. And then you've got these even finer root hairs that you can't see, with the naked eye. And then we're up to, I think that's, I can't remember, that's about 400 times magnification there. So you hear people talking about mycorrhizal fungi. So here we are up at 600 times magnification, and you can see there's a root cell there, there's a root cell there. That is a mycorrhizal fungal spore inside the plant. So this is the reason I've done this is with linseed roots, is you can actually pull them out, extract them, and still see what's going on, even though they're dead and this is completely dry soil. So there's in a buscular, well, I think it's in a buscular mass inside the root cell. So these fungi live inside the cells of the plant, and then they grow a filament out through the plant and out into the soil. So these things are absolutely microscopic. And these fungi can, I mean, they can exude acids and whatever they need. They can dissolve rock, essentially. So if you put starter fertiliser down with your seed, you won't develop many of these associations. So, you know, we're looking at different ways of how we mobilise and manage nutrients, because that's ultimately how we grow plants. So carbon, very briefly. In the system we're running, we're putting all this crop residue on top of the soil, and then we're trying to encourage the microbes which create a rhizosheath, so the carbohydrates come out of the plant. The microbes live on the carbohydrates that come out of the plant. They form a substance which isn't really a substance, but for the purposes of this exercise, called glomalin, which is sticky, and it causes this rastafarian roots, and that photo was courtesy of Nicole as well. But this is seedlings that wheat seedlings that are developing good microbial associations early in their life, and having carbon in the soil as the vehicle by which energy is transferred through the system. It's how the nutrients are transferred through the system. If you have low carbon soils, and it's a relative thing, but if you have low carbon soils for your situation, then you're going to have a low ability to be able to circulate nutrients through the system. So this is a case study, a horse farm I bought. So it's Temuka clay, 1 to 4 metres deep, essentially 50 years under horses, so it'd been bare. That's essentially about all that ever grown, and you can see that's about the extent of the roots, and you've got this lovely multicoloured layer cake. The material down there is exactly the same as the material there, but it just has no carbon in it, and it's been packed down over the years. So this is a transition story. I thought, well, I better test my metal. I haven't done this for a while. So how quickly can I convert this farm to get it up and humming? And went tits up for a couple of years, because we had 2 very, very wet years, and the water wouldn't drain through the profile, and we had pretty lean cropping situation. But then the dry came along, and these heavy clay soils, they crack. So I dug these holes, and you can see the cracks going down, and that's a 500 millimetre deep hole. And so this part of the paddock yielded about 8 to 10 tonnes of the hectare, and this part of the paddock 3. And you can see we've got it's not a pan, but there's a barrier layer there. It's not that hard, but and it was wet underneath and dry on top, and there's relatively small root ball there, whereas the root ball here goes down quite a way. And so that's, and this is by allowing that wet, dry, to crack your soil open. Even though we've got irrigation, I could keep it wet all year round, but the natural process of this soil is to crack open, the material falls down the cracks, you get organic material, you get, we apply lime when it's dry, and it falls down the cracks and gets down into the bottom of the soil. Then the plant roots can follow it down, the worms can follow it down, the microbes can follow it down, and you can build your soil depth. That's what soil building is. It's just building that carbon layer in the soil, building that rooting depth, because that's how we're going to build resilience into the system for water and nutrients. This is at home, and it's not a very good photo because it was really wet when I took it, but you can see so this has been under no-till since 1976, and you can see that's the original soil depth, and you can see that feature there and that feature there. As I couldn't be bothered digging a big hole, so I tried to shove the camera down a small hole. It wasn't really very easy, but anyway. And you can see that the streaking of the carbon down into the clay. And that was when, I remember as a kid driving the last year we were doing cultivation, and driving, and Dad put me on the tractor and he said, well, with the Cambridge roller and the harrows, go round and round and round and break this down into a seed bed. Oh, it's just impossible. And it was grey, it was never black. And this is where we're getting to. We're getting So that was yellow, completely yellow at that point there, and that's at that point there down. So it was a layer cake, same as the other soil. And that's, so, you know, you can achieve these things, and I think with what I know now, I can do it a lot quicker than I used to, and cover crops are the key component. So the slides will be available afterwards. They're just a range of products that you can use instead of chemicals to solve certain issues that you might run into on farms. It's certainly not comprehensive, and that'll have to do. So I'm told we've run out of time. So I'm sorry it was a bit disjointed and all over the place, but it's a lot to get through.
Awesome. Yeah, I'd hate to have to try and navigate that big brain of yours, Simon. Which I've tried to do on many occasions, and it usually takes about 3 hours over a cup of tea in the morning. And I'm still hungry for more, so thanks very much for that. We're going to pile up quite a few of the questions for this to the panel session, so we'll make sure we cover those. But any particular questions for Simon right now that are burning that you just can't hold on to? Any bigger questions coming to mind that you want us to sort of to note down and come back to later with the broader panel?
I got one for the panel. It's often mentioned that New Zealand already has high soil carbon with our current system. Why do we need to grow our soil carbon or build our soil carbon? You mentioned 10%. That seems like a huge gain to maybe where the average is at. Is that achievable and is that like beneficial to?
Cool.
Could be a panel.
We'll say that, but we'll talk concentration in depth. Good question. Any others bubbling up?
Probably transition of the crop from crop to cultivated. How does that?
Cool. So yeah, so maybe some learnings if you were from starting from scratch, what that process looks like, and things to watch out for. And Ross will be probably touching on a bit of that as well. Also, there's another one.
Yeah, something similar. Just if you were transitioning from a grass pasture-based system into cropping, and say you were to underseed, as opposed to using Roundup, would you just smash it with cattle just before it's popped up, or that kind of transition from a grass into the crop?
Cool. So would that effectively be an organic transition, or just?
Yeah, organic transition.
Yeah. Okay, cool. Any more? Yep.
We're talking about that you're using Roundup on an annual basis. Doesn't that do a lot of damage to soil biology?
Ask any agroecologist and I'll tell you it's a lot less harmful than using cultivation. And I would, from my experience, I would say that is absolutely true. And I think a healthy soil is more resilient to any intervention that you take. Roundup supposedly disrupts the fungal diversity in the soil. The testing we've done doesn't show that, and we've been using it for 50 years. But I think it's used far too much. I mean, I use it as a primary cultivation tool, and that's all I use it for. So, and I don't use it on every paddock every year, although we, for all intents and purposes, say use it once a year. Yeah, but because sometimes you use it twice when you're doing winter spring proper. But I don't. There's a lot of hype about Roundup and very little research, and it seems to be all the research has been done by the chemicals who want to sell the product, and then there's a large vocal bunch of people who think it's the worst thing since Hitler, but they haven't spent any money on research, so it's difficult. As a farmer, I have no capability or resources to do that research. All I can do is look at what I've done in the past and where my soil is at and measure the biological activity of that soil and make my own conclusions, which wouldn't be popular amongst those vocal people because they just don't bear out the claims. I think where the problems come in is where Roundup has entered the human food chain, where the companies have made these GMO crops which have just bred superbugs and super weeds, and they spray and spray and spray with Roundup, and it's going to get into the human food chain in quite high concentrations, and that's not ideal. And ironically, if you live in the North Island, you eat the bread you eat is made out of imported flour, wheat. If you live in the South Island, it's all New Zealand grown. And if you buy animal feed from CRT or anyone else, it's full of GMO soybeans, which are full of Roundup, because they don't want to spend the money to grow the crops in New Zealand. So they import all this crap from overseas, and so that's how it's getting into the food chain in New Zealand.
I think just to touch on that, around things like Roundup or cultivation, and there's a lot of can't do this, can't do that, this is bad, this is better, and that kind of thing. I think there's an emerging kind of maturity around that conversation. Like every tool can be used better or worse, and some for certain situations and some for others. And so the difference in the way that I've observed Simon and some of the other cropping farmers using Roundup is wildly different to how Roundup is used in other parts of the country or other parts of the world. And it's that kind of threshold. It's like, well, there's a little bit of cultivation gonna completely upset your system if you're using it little and often and wisely, versus using it all the time in a particular manner. And it's just really trying to bring a bit, I think what we're trying to do is bring a bit more of a maturity to that conversation, dive into the nuance rather than making blanket statements about what's right and wrong, but good questions to ask. And there's some some cool lessons that yourself and others have picked up around some of the smart and clever ways you can use glyphosate at lower rates to increase its effectiveness, but we won't dive into that now. But certainly happy to chat to Simon if you're interested in that kind of thing.
Well, I think as both Guy and Jules pointed out, you've got the tools and the tools. We don't have any rules. It's not like organics where you can do this and you can't do this and you can't do that. We've got all the tools in the toolbox. If you need to use them, use them. But I'd steer away from insecticides. We haven't used them for years. We don't need them.
Cool. Right, we're going to wrap up there and move on. Thanks very much. Everyone, let's take 60 seconds to get the bread.